Hello everyone and welcome back to Nunley Math. I'm Aaron Nunley. Thank you so much for joining me here today for the second in our series of pre-algebra videos on algebraic properties and equations. Basically, we're looking at those ideas or principles that help us transition from elementary school mathematics to high school, more abstract thinking. In our last video, the first video in this series, we talked about how we see certain patterns emerge in early elementary school that give rise to certain patterns that we can represent symbolically. And we use that to help us talk about the commutative and associative property and how those can be used to simplify algebraic expressions. If you have not seen that video, or if you are still uncomfortable with that topic, I'm going to highly recommend that you go back and watch that before watching this video, because this lesson does rely heavily on some of the ideas we learned in that lesson. This lesson hopefully will be a lot shorter. I know that last one got just a little bit long, and that tends to happen in the first video of a series because we're really laying down some foundational principles. We're only going to talk about one property here today, and that is the distributive property. And then we're going to give you an opportunity to practice that, and then we're going to tie up a bunch of loose ends in video number 3. So let's go ahead and dive right in. Here's a problem I want you to think about. Mr. Nunley has decided to treat the math department to a trip to the movies. He, Ms. O, Miss S, Mr. M, and Mrs. L arrive, and Mr. Nunley decides to spring for snacks as well. He buys a bag of popcorn and a large drink for each person. Give an expression that represents the total cost that Mr. Nunley paid. Now, when I say give an expression, what I'm looking for is one long string of numbers and operations that you could use to answer this question. So I'm not looking for lots of random mathematical facts loosely tied together on your page, but I'm looking for a single mathematical expression using adding, subtracting, multiplying, dividing, numbers and variables that you could use to represent this idea. I'm going to recommend that you pause the video, you think about this for just a little bit, you try it on your own, and then if you figure it out or if you get stuck, go ahead and restart the video to see how I work it out. I'm going to assume you've already done that, and I'm going to go ahead and keep right on going. Typically, students will think about this problem in one of two ways. You'll always have a certain group of students that think about this as the total cost for each person times the number of people. So if I know how much it costs for my stuff, and I assume that's the same for everybody else given the prices that are shown on the top, then I just take my stuff and multiply it by 5, and that should tell me the total cost. My other option is to think of it in terms of what each item costs and then add that up. For example, how much does the popcorn cost? How much does the large drink cost? How much do the tickets cost? And once I know each of those, I can add those up and tie it all together. If you got stuck and that sparked some thoughts for you, again, I'm going to recommend that you pause the video and you go ahead and try it. If you're a student who was able to figure out one of those methods, I recommend that you pause the video and see if you can figure it out using the other method as well. Again, I'm going to assume you've already done that, and I'm going to keep right on going. So we're at the movies, and we have two different ways to think about the problem. The total cost for each person times the number of people, or the total cost for each item, and then add those all together. Let's work those out separately. If I think about the total cost for each person, I know there are 5 people, and I know each person gets a ticket, a bag of popcorn, and a large drink. Or I have 5 people, and each person gets a $12 ticket and a $7 bag of popcorn and a large drink. Notice that what's in these parentheses is the cost for each item for one person. So a $12 ticket and a $7 popcorn and a $9 drink means each person is going to cost $28, or the items for each person is going to be $28. And since there are 5 people, 5 28s means the total cost would be $140. That's one way to look at the problem. The other way is to say, well, I'm going to have to buy 5 tickets, and I'm going to have to buy 5 popcorns, and I'm going to have to buy 5 large drinks. And we can think of those items separately. Well, if each ticket is $12, I'm going to have to pay 5 12s. And 5 popcorns, if each popcorn is $7, I'm going to have to pay for 5 7s. And each drink is $9, there it is right there, which means I'm going to have to pay 5 9s. Or I'm going to pay $60 in tickets, $35 in popcorn, and $45 in drinks for a grand total of $140. Notice, regardless of which way I think about the problem, the amount that I pay stays the same. It's just a matter of how I organize my thoughts. The distributive property teaches us that if you have 5 of a group, it's the same as having 5 of everything in the group. So if I have 5 people and each person has a total cost of $12, that's the same as saying I paid for 5 tickets and 5 popcorns and 5 drinks. It's just a way of organizing our thoughts. Let me give you another example, just a little bit differently. And here in plain language, I've got the distributive property slightly written different. Having 3 groups is the same as having 3 of everything in the group. And here's a picture to illustrate that. In my class, we teach this lesson around the holidays. So I have 3 reindeer, and I have 3 elves, and I have 3 Santas. 3 reindeer, 3 elves, and 3 Santas. But over here on the right, I'm going to organize that slightly different. Notice I have the exact same items, but instead of keeping all my reindeer together, and all my elves together, and all my Santas together, I've regrouped them. I now have 3 groups, and each group has a reindeer, an elf, and a Santa. What I have has not changed it. I've just changed how I've organized it in my mind. That's the distributive property. 3 reindeer and 3 elves and 3 Santas is the same as 3 groups with 1 of each. Does that make sense? Here's another one. In plain language, having 4 groups is the same as having 4 of everything in the group. So up here I have 4 Batman, 4 Batmans, 4 Batsmen, I don't know, we'll just play with that. 4 Spider-Mans, Spider-Man, Spider, I don't know. I have 4 Hulks, that one's easy, and I have 4 Thors. 4 Batmen, 4 Spider-Men, 4 Hulks, and 4 Thors. Over here, I have the exact same objects, the exact same superheroes, but this time, instead of grouping all the Batmen together, I've created 4 groups, and each group has 1 of each person or character. Here I have 4 groups, and each group has a Batman, a Spider-Man, a Hulk, and a Thor. Notice the objects haven't changed. I have the exact same objects. I've just changed the way I've grouped it in my mind. The distributive property would say 4 Batmen, 4 Spider-Men, 4 Hulks, and 4 Thors is the same as having 4 groups and having 1 of each in the group. How does that help us mathematically? Well, in a little more formal way of saying that, I could say to multiply a sum by a number, multiply each term inside the parentheses by the number outside the parentheses. You can see why I didn't give it to you that way at the beginning. And to make it even more mathy, I could write it like this. If I have this many groups, then I have this many of everything in the group. So I have this many B's, that's here, and I have this many C's, that's here. Here's an example. And this is one you might come up against in a homework assignment or in a textbook. I have 5 groups, and every group has an X in it and a 4. Well, that's the same as saying I have 5 X's and I have 5 4s. I have 5 of everything in the group. 5 X's and 5 4s. Now, I don't know what 5 X's is because I don't really know what this number is, so I'm going to hold on to that for a second. I do know that 5 4s makes 20, so there's my answer. 5 X's and a 20. That's the distributive property for you. Now, you might want to pause the video, try this one on your own, then restart the video to see if you understand this or not. I have negative 4 groups. Every group has a Y and a 9 in it. That's negative 4 Y's and negative 4 9's. Negative 4 Y's and negative 4 9's. I don't know what negative 4 Y's is, but I do know that negative 4 9's is negative 36. Again, this is going back to our study of positive and negative numbers in an earlier unit. Notice a couple things here just really quickly. You'll see that I'm using my mouse to draw little arrows between the 4 and the 9, it's a good idea, especially early on when you're doing these, to make sure you draw your arrow to both of those items. That helps you remember to give that -4 to both. It's very common for students to remember to give it to the first item and forget to give it to the second. That's why I'm showing so many steps here. By the way, you'll notice that I did at the end turn my plus negative back into a minus sign. We don't like to work with subtraction, but sometimes when you're finished, your final answer looks a little nicer if you change it back. I would accept either of these answers if you were in my class. Don't let it throw you off if I put the outside number on the other side. Remember, this is just multiplication, and the commutative property says it doesn't matter which one goes to which side. The 7 has to go to both. I have 7 B's and I have 7 11s. 7 B's I can't do anything with, but 7 11 I can just turn into 77, and we're done. One more. Here's one more. I have -3 3x's, and I have -3. Notice this minus sign. I don't like this. This gets confusing to me because I've got a minus sign here and a minus. It really is problematic. I'm going to suggest that before you distribute, you change that to a plus negative, especially early on. It's going to really help you keep your sign straight. Now I have -3 3x's and -3 -10s. -3 times 3x is -9x. -3 times -10 is a positive 30. If I hadn't changed that at the beginning, I would have ended up with like a minus -30, and that just is really a whole lot harder for students to work with. And I put a box around it. That's basically it. This one, you'll notice, was pretty quick, pretty short, pretty to the point, but it is an extremely important idea, and it does require a lot of practice. So that's why I've given it its own day. Our next video, we'll talk about how we can take the distributive property and use it along with our commutative and associative properties to solve increasingly complex problems or to simplify increasingly complex expressions. But I think this is enough for now. As always, I do appreciate you taking the time to join me here today. I do appreciate you taking the time to watch the video. Make sure you ring that bell to turn on your notifications, and make sure you subscribe to our channel so you can see all the new math coming out of Nunley Math. You guys take care of yourselves, all right? Have a good day. Bye-bye.